This question is from GATE 2015 Mechanical Engineering paper, Set 1, question number 36. The solidification time of a casting is proportional to V by A whole square, where V is the volume of the casting and A is the total casting surface area losing heat. Two cubes of same material and size are cast using sand casting process. The top face of one of the cubes is completely insulated. The ratio of solidification time for the cube with top face insulated to that of the other cube is dash. So we are being given solidification time, let that be T, is directly proportional to V by A whole square, where V indicates volume of casting and A indicates the area from where heat is being lost. So in the first case, if we say solidification time is T1, volume is V1 and area is A1, we can have the relationship here. T1 is equal to some constant K into V1 by A1 whole square. This indicates the Porinov's rule, where this constant is a factor of the material. So if the material is same, this factor remains same, and hence for the second case, if we have solidification time as T2, volume as V2 and area as A2, we can write the relationship between these two. So one thing, T1, T2 will be different, of course. That's what ratio we have to find out. V1 and V2 are given equal because the cubes have same size. Their volume will be same. So we have V1 is equal to V2. Let it be equal to V. Because this is a cube, volume will be A cube. With same size, both volumes are equal, A cube. But for areas, we will have to see in the first case, all faces are losing heat. So the area, total area that loses heat is nothing but area of all the faces together. A cube has 6 faces. Area of one face is A square, side square, and therefore area from which heat is lost, A1, is 6A square. Similarly, we can write A2. A2 has one face insulated, and that is why that face which is insulated will not lose heat, and therefore that area will have to be subtracted. So how many faces remain now? 5 faces, and the area of one face is square of side A square. Now we found out V1, V2, A1, A2. We can find out the ratio for T1, T2. Let's go ahead. We ought to find here T2 by T1. So let's calculate this ratio. The ratio for solidification time taken for the insulated cube divided by the non-insulated cube. That is why we have taken T2 by T1. This will be equal to, in the second case also, we have the relation T2 is equal to K, or constant remains same, V2 by A2 whole square. Let's put it here. We have V2 by A2 whole square divided by V1 by A1 whole square. This can be simplified. V2, V1 are equal to V. So numerator get cancelled. V2 square by V1 square. We get this as A1 by A2 whole square. Let's put the values for areas. We have A1 as 6A square divided by A2 is 5A square. Square of this again, because this is A for area. This square is for the solidification time expression. To simplify, we will have A square will get cancelled with each other. 6 by 5 whole square can be written as 6 square 36 divided by 5 square 25. So the ratio that we obtain is 36 by 25. Let's mark the correct option. The correct option here is option B, 36 by 25. For more information on casting, you can refer to the NPTEL video, The Pattern Allowances 1, from the course Fundamentals of Manufacturing Processes by Dr. D.K. Dwivedi. He is from Mechanical and Industrial Engineering Department from IIT Roorkee. I hope this solution will help you clear your doubt. Thank you.